Imagine this. You're an astronaut performing a routine spacewalk outside the International Space Station. Suddenly disaster strikes. Your tether snaps, sending you hurtling away from the station into the abyss of space. Panic sets in. You're completely alone, adrift in the void. What do you do? This terrifying scenario, while fictional, highlights the very real dangers of space travel. The unforgiving environment of space is a constant threat to human life. It's a place where even the smallest mistake can have catastrophic consequences. In this essay, we'll explore the challenges of survival in space. Space is a hostile environment, unforgiving and indifferent to human life. It's a realm where even the smallest mistake can have catastrophic consequences. It's a vacuum, devoid of the air we breathe and the pressure that keeps our bodies intact. In this void, there is no sound, no atmosphere, and no mercy. Exposure to this vacuum would lead to a rapid loss of consciousness, followed by death within minutes. The human body is simply not designed to withstand such conditions. But the vacuum is just one of the many dangers lurking in space. The cosmos is filled with threats that can end a mission in an instant. Extreme temperatures, ranging from the scorching heat of direct sunlight to the frigid cold of shadows, pose another serious threat. These temperature swings can be as drastic as hundreds of degrees. Without the Earth's atmosphere to regulate temperature, spacecraft and astronauts need specialized systems to survive these drastic fluctuations. Thermal control is a constant challenge. Then there's radiation, invisible yet deadly energy constantly bombarding our planet from the sun and deep space. This radiation can penetrate living tissue, causing severe damage. While Earth's magnetic field shields us from the worst of it, astronauts are exposed to much higher levels, increasing their risk of cancer and other health problems. Prolonged exposure can have devastating effects. Long-duration space missions require innovative solutions to protect crews from this invisible threat. Advanced shielding and protective measures are essential for survival. Finally, we have microgravity, the weightlessness experienced in orbit. This unique environment affects every aspect of an astronaut's life and work. While it may look fun to float around like astronauts do, it has serious long-term effects on the human body. The lack of gravity leads to muscle atrophy and bone density loss. Muscle and bone loss, cardiovascular issues, and even changes in eyesight are just some of the challenges posed by prolonged exposure to microgravity. These health issues require constant monitoring and innovative countermeasures. Understanding these harsh realities is crucial for appreciating the challenges of space travel and the importance of developing effective survival strategies. Every mission is a testament to human ingenuity and resilience. In the next section, we'll delve into some historical space missions that put these challenges into stark perspective. These missions highlight the bravery and determination of those who dare to explore the final frontier. The vastness of space holds many dangers beyond the vacuum, extreme temperatures, and radiation we previously discussed. Micrometeoroids, tiny particles traveling at incredibly high speeds, pose a constant threat to spacecraft and astronauts. These particles, often no bigger than a grain of sand, can cause significant damage upon impact, puncturing hulls and disabling critical systems. Larger space debris, remnants of old satellites and rockets, adds another layer of danger. This orbital debris, traveling at thousands of miles per hour, can collide with spacecraft, causing catastrophic damage. Tracking and avoiding these hazards is a constant concern for space agencies worldwide. Then there's the psychological toll of prolonged space travel. Confined spaces, isolation from loved ones, and the constant awareness of being far from home can take a toll on mental well-being. Astronauts are carefully selected and trained to withstand these pressures, but the psychological challenges of space travel remain an important consideration. The combined effect of these cosmic hazards creates a uniquely challenging environment for human exploration. Overcoming these challenges requires a multifaceted approach, from rigorous astronaut training and spacecraft design to the development of advanced technologies and a deep understanding of the human body's response to space. Section 4, Close Calls in the Void, when space exploration went wrong. The history of space exploration is filled with tales of daring missions and groundbreaking achievements. From the first steps on the Moon to the construction of the International Space Station, humanity has continually pushed the the boundaries of what is possible. But it's also a sobering reminder of the inherent risks involved in venturing beyond Earth's protective atmosphere. The vacuum of space, the potential for equipment failure, and the unknown variables all contribute to the dangers faced by astronauts. Over the years, there have been several near disasters and tragedies that highlighted the unforgiving nature of space and the importance of constant vigilance. Each mission carries with it the potential for unforeseen challenges that can quickly escalate into life-threatening situations. One of the most well-known spaceflight emergencies is the Apollo 13 mission in 1970. This mission was intended to be the third manned lunar landing, but it quickly turned into a fight for survival. An oxygen tank explosion crippled the spacecraft en route to the moon, forcing the crew to abort the lunar landing and fight for their survival. The explosion caused a loss of power and a critical drop in oxygen levels, making the situation dire. Thanks to the ingenuity and resourcefulness of the astronauts and the tireless efforts of ground control, the crew of Apollo 13 managed to return safely to Earth. Their safe return was a testament to human resilience and the power of teamwork. Another harrowing incident occurred in 1967 during the Apollo 1 mission. This mission was meant to be a pivotal step in the journey to the moon. A fire erupted inside the command module during a pre-launch test, tragically killing all 3 astronauts on board. The fire spread rapidly and the crew had no chance to escape. This disaster led to a thorough review of safety procedures and spacecraft design, resulting in significant improvements for future missions. The lessons learned from Apollo 1 have been integrated into every subsequent mission. These incidents, while tragic, serve as important reminders of the risks inherent in space travel. They honor the bravery of those who have ventured into the unknown and underscore the need for continuous improvement. They underscore the need for robust safety measures, rigorous training, and a relentless pursuit of technological advancements to mitigate these risks and ensure the safety of future space explorers. The quest for knowledge and exploration must always be balanced with the utmost care for human life. Section 5. Prepared for the unknown, astronaut training and emergency drills. Venturing into the unforgiving environment of space requires astronauts to be prepared for any eventuality. Their training is a rigorous process, pushing them to their physical and mental limits to ensure they are ready for the challenges of spaceflight. Astronauts undergo extensive training in a variety of areas, including spacecraft systems, robotics, extravehicular activity, and emergency procedures. They spend countless hours in simulators that mimic the conditions of space, practicing launch sequences, docking maneuvers, and emergency protocols until they become second nature. A crucial aspect of their training involves preparing for emergencies. Astronauts practice responding to a wide range of scenarios, from fires and depressurization to equipment malfunctions and medical emergencies. They learn to work effectively as a team, relying on their training and each other to solve problems and overcome challenges. This rigorous training is essential for ensuring the safety and success of space missions. It equips astronauts with the knowledge, skills, and mental fortitude to handle the unexpected and respond effectively to any situation that may arise during their journey into the cosmos. Section 6. Safe havens in the void. Spacecraft and station safety features. Spacecraft and space stations are designed with numerous safety features to protect astronauts from the harsh realities of space. These features are meticulously engineered to ensure that astronauts can carry out their missions safely and effectively. These engineering marvels are built to withstand the rigors of launch, the extreme temperatures and radiation of space, and the potential hazards of micrometeoroids and space debris. The structural integrity of these vessels is paramount, as even a small breach can have catastrophic consequences. One of the most critical safety features is the spacecraft's pressure vessel, which maintains a breathable atmosphere for the crew. This vessel is designed to be airtight, ensuring that the life-sustaining environment inside is preserved at all times. This sealed environment protects them from the vacuum of space and provides a comfortable temperature and pressure for living and working. The pressure vessel is also equipped with systems to regulate humidity and remove carbon dioxide, ensuring the air remains safe to breathe. Redundancy is another crucial aspect of spacecraft design. This means that for every critical system, there are multiple backups in place. Critical systems, such as life support, propulsion, and communications, often have multiple backups in case of failure. This redundancy is essential for maintaining the functionality of the spacecraft in the event of an unexpected malfunction. This redundancy ensures that even if one system malfunctions, the crew has a backup to rely on. For example, if the primary life support system fails, a secondary system can take over, preventing a potentially life-threatening situation. Spacecraft and stations are also equipped with radiation shielding to protect astronauts from the harmful effects of cosmic rays and solar flares. This shielding is crucial for long-duration missions, where prolonged exposure to radiation can pose serious health risks. This shielding is typically made of materials like aluminum, polyethylene, or water, which absorb or deflect radiation particles. Each material has its own unique properties that make it effective at blocking different types of radiation. Furthermore, advanced fire suppression systems are in place to quickly detect and extinguish fires, which can be particularly dangerous in the confined environment of a spacecraft. Fires in space can spread rapidly due to the lack of gravity, making quick suppression vital. These systems often use carbon dioxide or other fire-suppressing agents to starve fires of oxygen. This method is highly effective in the enclosed spaces of a spacecraft where traditional firefighting techniques may not be feasible. These are just a few examples of the many safety features incorporated into spacecraft and space stations. Each feature is designed with the utmost care and precision to ensure the safety of the crew. These engineering marvels are a testament to human ingenuity and our ongoing quest to explore the cosmos while ensuring the safety and well-being of our astronauts. The continuous advancements in technology and engineering are what make space exploration possible and safe.